Welcome to Educator.com. In today's lesson, we'll be discussing properties of real numbers. A real number corresponds to a point on the number line, and real numbers may be either rational or irrational. So first, just talking about the number line. Some examples of real numbers would be 0, 1, 1/2, or expressing a number as a decimal, it could be 2.8. Negative numbers, maybe negative 2.18, negative 4. Okay, these are all real numbers and they are rational. So let's talk about the difference between rational and irrational numbers. Rational numbers can be expressed as a fraction. A rational number can be expressed as a fraction. So rational numbers are expressed in the form a over b, where a and b are integers, and b does not equal 0, because as you'll recall, we cannot have 0 in the denominator, because that would result in an undefined expression. When a rational number is expressed as a decimal, it will either be terminating or repeating. Let me explain what I mean by this. If I have an example such as 1/2, and I convert that to decimal form, it's going to terminate. It's 0.5. I might have another number, 1/3, which is also rational, and it's going to end up being 0.3333 and on indefinitely. This could also be written as 0.3 with a bar over it, indicating it's repeating. So this is also rational because it repeats. The repeating pattern could be longer. It could be, 2.387, 387, 387. So this is repeating. The point is they either terminate or repeat when expressed in decimal form. Irrational numbers cannot be expressed in the form a over b. And when they are put in, so they're expressed as decimal form, but they neither terminate nor repeat in decimal form. They just go on indefinitely. For example, I could have 4.871469837246 and on and on and on, with no pattern, no repeating, and no ending. Another example would be pi. We often express pi as 3.14, but it actually goes on and on indefinitely. So it's just approximately equal to 3.14. Therefore, we can add pi up here. That's an irrational number to represent some irrational numbers on here. In addition, the square root of numbers other than the square root of numbers that are perfect squares are irrational numbers. So square root of 3 or the square root of 2. If it is a perfect square, that means it's the result of multiplying an integer by itself. For example, 2 times 2 is 4, so that's a perfect square, and the square root of 4 is rational. In fact, it just equals 2. All other square roots are irrational numbers. So again, both rational and irrational numbers are real numbers, but they have different properties. Sometimes we express the relationship between the various types of real numbers using a Venn diagram. So I'm going to go ahead and break down the real number system into its subsets and then show you how this works as a Venn diagram. So we have the real number system. And we have irrational numbers. And we also have rational numbers. And a Venn diagram is a visual way of understanding the relationship between these and their various subsets. So you could use circles. I'm using rectangles and squares, whichever. So irrational numbers, this is sometimes just known as Q, the line over it. And some examples that I just discussed, the square root of 2, pi, the square root of 5, these are irrational numbers. And then I have rational numbers, sometimes expressed as Q. Okay, this is the real number system. Within rational numbers are some subsets. The first one is the natural numbers. And the natural numbers are the numbers that we use to count things. So 1, 2, 3, and on. They're the numbers we use in counting. There's a slightly bigger set of numbers known as the whole numbers. The whole numbers include the natural numbers. So this square is around the natural numbers because it includes all those. And it also includes 0. So we add 0 to this set and on. Does not include negative numbers. Next are the integers. The integers include natural numbers, whole numbers, and also negative numbers. So 0's included and on. Okay. So when you can come out to just rational numbers that are not whole numbers, natural numbers, or integers, and you can get fractions included, like negative 1/2, 0, 1, 2, 3/2, and on. So real number system is broken down into rational and irrational, and rational numbers are further broken down into the natural numbers, the whole numbers, and the integers. In algebra, it's important to understand the properties of real numbers, what it is you're allowed to do and not allowed to do when working with real numbers. So recall the various properties: commutative, associative, identity, inverse, and distributive. So reviewing those, the commutative property applies both to addition and multiplication. And what the commutative property tells us is that two terms can be added in either order or multiplied in either order. So if I have two numbers, a plus b, I can change that order, b plus a, and it's not going to change my result. For multiplication, the commutative property under multiplication, I could say a times b equals b times a. The associative property also applies to both addition and multiplication. The associative property tells you that when you're adding or multiplying, the terms can be grouped in any way and the result will be the same. Remember that we sometimes use grouping symbols with expressions and equations. So looking at this, I could group it as a plus b plus c, or I could group it as a plus and then parentheses b plus c. Group those together. Either way, they're equivalent. It's not going to change my result. The same holds true for multiplication. If I have a times b times c, that equals a times b times c. And it doesn't matter if I decide to group it like this or like this, if I multiply these first or these first. The identity property, when I think of this, I just remember that the identity property tells me that the number maintains its identity. It doesn't change. So for addition, what this says is that the sum of any number and 0 is the original number. So a plus 0 is still a. So the identity of the number doesn't change just because you add 0 to it. For multiplication, the product of any number and 1 is the original number. So that's the identity property under multiplication. So a times 1 is still the original number a. The inverse property as applied to addition says that when you add the same number but with the opposite sign, so a plus negative a, or say 3 plus negative 3, the result is 0. So a number plus its additive inverse is equal to 0. This property can also be applied to multiplication, and this only applies to real numbers other than 0. For real numbers other than 0 when applied to multiplication, and you'll see why. What this says is that if you multiply a number by its reciprocal with the same sign, the result will be 1. We can't apply 0 here because that would give us a 0 in the denominator, which is an undefined expression. So a number times its reciprocal gives you 1. Finally, the distributive property. And you can review more about this in the Algebra 1 lectures. This is a very important property when working with equations, solving equations, working with algebraic expressions. Recall that a times b plus c equals a times b plus a times c. So we go forward to multiply, and when we go in the reverse direction, recall that that's factoring. This property also applies to multiplying a number by terms that are subtracted, so ab minus ac. If you put the numbers you're adding first, it doesn't change the property. It still applies. You get AB plus AC. Same for subtraction. And finally, recall that this property can be applied to several numbers. So you can have more than 2 numbers in the parentheses. This could be A times B plus C plus D, and then you just multiply each one out. AB plus AC plus AD. And again, this is something we're going to be using a lot throughout the course. All right, applying some of these concepts to the examples. Example 1, what sets of numbers do these belong to? Starting with 6. Well, 6 is a real number. It's also a rational number. I can easily express this as a fraction, 6 over 1. And so it's a rational number. Then I think about the subsets. Is it a natural number? Yes, it's a number that can be used in counting, 1, 2, 3, 4, etc. So it's a natural number. And it's therefore also a whole number. The whole number encompasses the natural numbers. And it's an integer. So 6 belongs to all these categories. The square root of 20 is a real number. However, recall that unless you're talking about the square root of a perfect square, it's irrational. Square roots of perfect squares are rational. Other square roots are irrational. Negative 4/5. This is expressed as a fraction. So, well, it is a real number. And it's also rational because it can be expressed as a fraction. It's not a natural number because it's negative and it's a fraction. Same thing, it's not a whole number, and it's also not an integer. So this belongs to the two groups, real and rational. Okay, this example 2 asks what properties are used. So there's an expression here, a mathematical expression, and various steps are taken. So we need to determine which properties were used that allowed those steps to be taken. Well, looking at what happened between here and here, we started out with 2 times 4 plus 3 plus 7. The order of these were switched. 3 plus 7 is still grouped together in parentheses, but it was put before the 4. So remember that the commutative property is the property that says that when adding, you can change the order that you're adding terms in and still get the same result. So this is a commutative property. Okay, next step. I look at what happened, and this big set of parentheses is gone. And the way it was removed is by use of the distributive property. Recall that the distributive property says that A times B plus C equals AB plus AC. And that's what was done here. 2 times the whole expression, 3 plus 7, and then 2 times 4. So this is the distributive property. In the next step, the order of these two numbers was changed, so that's commutative. And a 0 was also added to 4. And remember that according to the identity property, you can add 0 to a number and the original number is unchanged because 4 plus 0 is 4. So this is commutative and identity. Finally, getting rid of the rest of these parentheses by using the distributive property, 2 times 7 plus 2 times 3 plus 2 times 4 plus 2 times 0. So again, using the distributive property. Example 3 asks, what is the multiplicative inverse of negative 6 over 7/8? Recall multiplicative inverse, the definition is a number times the reciprocal of that number. And recall that that equals 1. Okay, so the multiplicative inverse, I have negative 6 over 7/8. So I'm going to change this from a mixed number to a fraction. 6 times 8 is 48. Plus 7 is 55, and this is negative. So that's negative 55/8. So looking at it as a fraction makes it much simpler. And I just need to take the inverse of that, the multiplicative inverse. And so I would change that to negative 8 over 55. And it does satisfy this formula right here. Because if I took negative 55 over 8, which is my original number, and I multiply it by negative 8 over 55. Two negatives, negative times negative gives me a positive. The 8's cancel, the 55's cancel to give me 1. So I was able to check my work by seeing that it satisfies this equation. Okay, in example 4, we're asked to simplify and state the property used for each step of simplification. First, I want to get rid of the parentheses, so I'm going to use the distributive property. So multiplying out, recall that the distributive property is A times B plus C equals AB plus AC. Okay, this is 2 times 6x plus 2 times 3y plus 4z. So right now I'm just removing these outer parentheses. I'm keeping these intact. That'll take a second round. So plus negative 3 times the entire expression in the parentheses plus negative 3 times z. Okay, I'm going to apply the distributive property again in order to remove the remaining parentheses. So this gives me 2 times 3y plus 2 times 4z plus negative 3 times 3x plus negative 3 times negative y plus negative 3 times z. Now I'm going to multiply these out. This is 12x plus 6y plus 8z minus 9x plus, negative and a negative is a positive, so that gives me plus 3y minus, this is negative 3z, so it's negative 3z. Okay, now I'm going to group together like terms, and that's using the commutative property. I can change the order of these terms. So I have my x's, 12x minus 9x. I have my y's, and that is 6y and 3y. And then finally z's, 8z and negative 3z. All that's left to do is add like terms. So 12x minus 9x is 3x, 6y and 3y gives me 9y, and 8z minus 3z is 5z. So simplifying this using first the distributive property to remove the outer parentheses, then the distributive property to remove these other sets of parentheses, the commutative property to reorder this to group like terms, and then simply adding or subtracting. That concludes this lesson from educator.com. See you next lesson.